This is 2003 question 4b, slightly longer than the easier part A, which was probably too easy, but you never know what can happen. So this one, a block of mass 4 kilo, inclined at 60. And take these pieces of information and draw our own diagram. It's connected by a light inextensible string which passes over this smooth pulley here, and we've got an 8 kilo hanging at the end of it. So the 4 kilo really is the one to focus on. 8 kilo will be easy to do the equation. We've got coefficient here, friction 1/4. So we're looking for mu r. And then we've got this distance of 2 as well. So show t is 52. Correct to the nearest whole number. Okay, let's do our equations. Let's start off with the 8. It's nice and easy. We've got tension in the string. We've got mg, hg. And it's coming down in this direction, A. So we have hg minus t is equal to ma, 8a. So there's one equation you can set up quite quickly. If we look at the 4 kilo, I'm just going to give it this kind of diagram here. Got my 4. So we have mg, we have my reaction in this direction, call it or. Opposing or. We've got my angle in here, which is the same as this angle here with our alternate angles. Just identify that, and we know that that angle is 60 from the diagram. So we have 4g coming down in this direction, parallel to the slope and opposite the slope. So I have opposite the 60, I have 4g sine 60, and adjacent to the 60, I have 4g cos 60, and I have r is going to be equal to this opposing force here. So let's get this and get the mu r first. So r is equal to 4g cos 60 is the one going down. 4g cos 60, just be careful. 4g cos 60. So r is equal to 4g by a half. So r is equal to 2g. So mu r, which will be this force along the slope, mu r is equal to 2g divided by, we have this quarter up here. Here it is. So 2g times 1 over 4, which is equal to g over 2. So we have tension in the string this direction. We also have acceleration in this direction. So I could set up my equation now. I have t minus mu r, if you want to put it in like that first, minus this one here, also going in that direction, 4g sine 60. Just to give it its long form, this is equal to ma, which is 4a. So t minus mu r, which is g over 2, minus 4g sine 60. Sine 60 is root 3 over 2, so 2 root 3. G equals 4a. And if we bring the other equation down, we should be able to solve. So we've got minus t plus 8g is equal to 8a. And combining these two equations, bringing them up here, I'm going to get 12a. I'll just write that one first. 12a from these two here is equal to the t's cancel, and I'm going to have 8g minus g over 2 minus 2 root 3g. So this simplifies as 12a is equal to, well, that's 8g minus a half g, that's 7.5g, and then minus 2 root 3, both times g, which is 9.8. I think we need it in this case. So a is equal to 7.5 minus 2 root 3 by 9.8 over 12. can't do this in my head. I need a calculator. This is giving me 3.295. Correct to the nearest whole number. I'll take it as 3.3 ms to the minus 2. And we're asked to show tension in the string. So tension, maybe from this equation here. If I bring t to the right, I'll get t is equal to 8g minus 8a. So t is equal to 8 times g minus a, 9.8. That's 8g minus 8a, 3.3. So tension is equal to 8 times 6.5, 48 and 4. T is equal to 52 newtons. What were we asked to show? T is equal to 52 newtons. Okay, part 2. Let's see why this was a bit longer. How far has the block moved? How far has the block moved up the plane after 1 second? So here we have the block moving up the plane. So if we write our equation out for how far, distance s is equal to ut plus a half at squared. We've just found a to be 3.3. 1 second. We've got the half. Going backwards here for some reason. We have u is equal to 0. Starts from rest, so s is just equal to a half. 3.3 by 1 is just half of 3.3. It'll be 1.65. That's how far it has moved up the block after 1 second. And after 1 second, the string is cut. Determine whether or not the block will reach the pulley. After 1 second, the string is cut. So it's traveling in this direction. The string is cut. Is it going to get the extra bit to the top? So what's happening here? We need to get the speed. V is equal to u plus at. The speed at this point after 1 second, if it starts from rest, and the acceleration is 3.3. The speed of the 4 kilo is 3.3 meters a second. So now I need its new acceleration. So what was slowing it down before? We had mu r was slowing it down. So this is going to be my new forces. And we had the 2 root 3. So these two things here. The string is now cut, so there's no tension. So my new forces are minus g over 2 minus 2 root 3g is going to be equal to ma. Let me just call it a again. So a is going to be equal to, I'll actually just type this into a calculator, divide by 4, it's going to be minus, getting minus 9.71. No, I'm not getting it by putting a root 3 disappearing. That's what it should look like. So that's my new acceleration. I've got my new velocity. We want to see, does it go at distance? When it's gone 1.65, it's 2 meters from the top. So it needs to travel another 0.35 or more to get to the top. So if we use the equation v squared is equal to u squared plus 2as, we'll find out how far it travels when it comes to rest. So let's see, my u is 3.3 plus twice my new acceleration, which is minus 9.71 by s. So s is going to be equal to 3.3 squared divided by twice 9.71. So this is positive. Let's see how big it is. Is it more than 35 centimeters? Yeah, it is 56 centimeters or 0.56. Now, obviously, it's not going to travel 56 centimeters. It's going to get to the top and go that direction. So what are we asked? Determine whether it will reach the top. Yes. And you could write as if it was flat all the way, it would travel 35 5 plus 21, 56 centimeters, or whatever way you want to explain it, as you're gloating over getting this question correct in less than 10 minutes.